Good afternoon, folks. I'm Russ Hilley, and I work with SBA. I work with structural design and analysis, and I do software support for SDA software. And this afternoon, I'm going to go over a couple of things that have been asked of me in the recent months, and hopefully this will give you guys some help. And we'll just get started. We'll talk a little bit about the background of SDA for a second. We'll go over what we're going to cover, and we'll do the demo, and we'll close out with some Q&A. Depending on how much time we have left, you can always email your questions. My email and phone number will be on the last slide of the presentation. So feel free to email me any questions you have as well. All right, SDA was founded in 1997, originally doing just design and analysis. Our clients basically wanted to do lightweight and load-efficient structures in the aerospace and defense industries. And SDA, along with SDA software, has expanded that to include marine and energy. And SDA is a premier center of excellence when it comes to working with composites and lightweight structures. And we've been a Siemens PLM VAR since 2012. And you can see there on the map, there are some of our office locations. And our main office being in Sterling, Virginia. And then we have sales guys all over the country, myself in Georgia, and a couple other analysts that work remote as well. Hey, structural design and analysis, we've got about 30 engineers and designers that help our clients design lightweight, load-efficient structures. Again, we support aerospace companies and other industries that require detailed design and high-level analysis, and we specialize in composites and lightweight structures. And in doing so, we're currently involved in building our own 6-passenger composite single-engine commercial aircraft. And we use the tools, all the tools we sell and support. We use those on a daily basis, including STAR, PEDS, FEMAP, and NX Nastran, which is my specialty. FiberSim, NX CAD, Solid Edge, SimCenter 3D, AMASIM, Dina, and a couple of other applications for Flutter. And then SDA is 50% owner of SDA software, which is a value-added reseller for Siemens, as I mentioned earlier. And we provide software training and support for the products we use on a daily basis. Sales and support for all the products I mentioned earlier. I primarily do FEMAP and NX Nastran support, and we have guys who are very fluent with FiberSim, NX, and some of these others listed here that we can help with anytime it's needed. And if you ever reach out to our support line, that rings to my cell phone, and our support at sdasoftware.com email goes to a distribution of several of us, and it ensures that everybody's issue is taken care of. Our past and current projects, SDA, this is the composite aircraft, Roman Space Telescope, which I spent about 3 years working on. Some wind turbines, the Dream Chaser, a Mars sample return, and the Lockheed Lunar Lander. So just a few of our products. As I mentioned earlier, we're a Siemens value-added reseller for all the CAE and CAD software. We provide training, basic introductory training for FEMAP and NX Nastran, and then advanced FEMAP and NX Nastran training on demand for customer desired topics and FiberSim. Again, we do support these products, and if we don't know the answer, we have a great relationship with development teams. We can go directly to them and get your questions answered. Okay, so I want to move on into the webinar today. Basically in a FEM with many RBEs, if the part is remeshed, will the RBEs remain connected? That depends largely on how you mesh it. And then the other question, there are some methods of remeshing where the RBEs are definitely going to be disconnected. So how can you reconnect those without editing one by one? And then we're going to take a look at two common ways to model bolted connections in FEMAP. So to get a little deeper in this, we're going to talk about how rigid elements are updated when you remesh a part. And then we're going to take a look at an example of updating the rigid element connections after we've remeshed a part. And then under the bolted connections, we're going to talk about the hole-to-hole fastener, and it's an API that is shipped with FEMAP, and using the RBE2 CBUSH RBE2 method to model bolts. All right, there's a couple of methods of remeshing that is going to maintain the RBE connections. So if we are using the mesh surface or mesh sizing tool in the meshing toolbox, it's going to automatically reconnect. So I'm going to show you that here in just a minute. This will work for plate and tet meshes. For hex meshes, it'll work, but only if it's meshed using the mesh geometry hex mesh solids. The meshing tools, I have not had any luck getting those to update meshes when you create it with the hex mesh bodies command. We're going to take a look at a little bit of both here. So let's jump into FEMAP. And take a look. So what I'll do is I'll just create a couple of RBEs of these holes here. And I have meshed this surface with the mesh geometry surface or the meshing tools mesh surface command. And what I'm going to do is just create an RBE2. I don't know what skill levels of folks are online, but there may be some here not familiar. So I'll go modify model element and just change the element type to rigid. Hit OK. And if I had an independent grid created, I could specify that, or FEMAP would ask me to create it on the fly. But what I'll do is I'll just use this new node at center option. And for the nodes, when it comes to select nodes, I could select them one by one off the screen, or I could select them based on their relationship to a piece of geometry, which is what I'm going to do here. So grab the nodes on those curves and hit OK. I'm going to cancel this command and go through another one. If we go to the custom tools under the meshing category, we have these spider commands. I know many people are familiar with these, and you just choose spider curves. In this case, we'll take a look at using spider surfaces, but and then double clicking to accept the selection and just moving through each one, I can quickly create all the RBE2s for these holes. And let me just get the last two over here. And now I'm going to pop into my meshing toolbox, and I'm just going to, let's see, I'm going to just set the number of elements on these curves. I'm going to update the mesh around these curves. That's what we're interested in. Seeing how FEMAP can help reconnect the RBEs. And this has been a not too recent, well, let's see. Within the last couple of versions, I think this has been added. So I'll just set the number to 6. That'll give us a good idea. And we'll click on the curve, and you notice it will go ahead and update that. You notice it remeshes every time. So what I can do in the meshing tools as well is grab this dialog, select And I can just hold the control shift and start a dialog pick. I mean, a polygon pick there, my dialog, and it remeshes my component quite easily. Okay, so when you update a mesh using the meshing tools, it should update your rigid element connections as well. So let's move on to a couple of other types of meshes. I'm going to move to a solid TET mesh. We can do the same thing, except I'm not going to manually create an RBE. I'm going to use the API. And I'm going to go ahead and use the spider surfaces command and just walk around these, and we'll create our RBEs. And you notice this moves pretty quick. We don't have to, really don't have to create them all, but we will. Completeness here. You can just pick one surface and double click on the second one to set the selection. So if anybody was wondering about that. Okay, so now what I'm going to do is go ahead and use the same technique to update this mesh. You see it does connect the mid-side nodes here. So that'll update as well. So if I click there and grab my selection down in the entity info down here on the left, you'll see there's 4 elements on that curve. So yeah, we'll just set them to 8. And again, this remeshes every time. Let me just demonstrate that real quick. It doesn't take long to mesh this, but it does change every time. So what I want to do is make as many changes as I can in one command. So I'm just going to do a couple of these. Forgot to grab that one. And I'll just grab those, and I'll grab the back curves for use elements as well. We'll hit OK, and it'll create all of our change at one time. Again, if you notice, it updates our RBE to include the mid-side nodes on the TED elements. So using the meshing tools, you can update RBEs will update automatically for plate meshes and a TET mesh. Okay. All right, so I'm going to turn the select off there, and I'm going to move on to a, now this part was meshed using the mesh geometry hex mesh solids command. So again, when we first started out the time here, I mentioned that it will update hex meshes, but only if you've used this method to create them. Again, let's create a few rigid elements using the spider surfaces command. Again, I'll just grab and I'm double clicking on the second surface, which automatically accepts my selection. And that might make things a little faster. Not everybody knows that you can do that. You can double click on. The thing about the meshing tools on a hex mesh, I'm going to show you, it will should propagate that to the other side, propagate mesh sizing. So if I select, let's see how many I've got on these. There are 4 on these shown down in my entity info. Now, if I select just 2 of those and grab there, you see it did propagate that to the other side. So let's go ahead and we can go ahead and do that quickly for a couple of these. And you can see that it, again, it updates our RBEs so that we don't have to go back and start reconnecting RBEs. Okay, the next case I'm going to show you, I took a piece of solid geometry and I used this is the same solid from this one, which is a perfect example of a tet mesh, but I used the hex mesh bodies command to make it a little bit nicer than tet mesh here. So again, I'm going to create some RBEs, and I'm going to create all of them in this one because we're going to force it to disconnect them and then take a look at one way. I'm sure there are multiple ways, and I'm sure you could go through the API and create an API that would go and reconnect rigid elements for you. That would be handy to have, but I'm going to go ahead and just double clicking on the second selection on every hole, create all these RBEs. And I've got two more. So the next thing I'm going to do is I'm going to remesh this part. We've got, we're going to put a little finer mesh on it. So I am going to go and say mesh control, size on solid. And I am going to update it to just put mesh size of 0.125. And so that I get a better resolution around the hole, I'm going to change this max angle tolerance to 12. And then I'm going to use the hex mesh bodies command. It's already meshed, so it's going to ask me if I want to delete it and remesh. I do want to delete the existing mesh and remesh. Going to hit OK there. I want to use the curve sizing and all size curves. I want my mesh to be associative to all geometry. And for this one, I do not want mid-side nodes. I'm going to hit OK and allow it to go off and remesh that. It should take less than a minute to do, probably more like about 30 to 45 seconds, or maybe less. But if we look here, you can see that the RBEs are disconnected in a few places. It almost come back. Well, it actually, I think yeah. See, they're disconnected here at this interface. This line of nodes is not connected. And this line of nodes is not connected. So we need a quick way to do that. Now, one thing that you could do is you could go modify, edit, element. And if you only have a few, this technique would probably not save you a lot of time. But if you had a lot of these to do, we could reset the nodes in this RBE and apply new nodes based on our geometry. I'm going to cancel that because I'm not going to do it that way today. So here's what I'm going to do. I'm going to move this out where we can see it a little better. And I am going to switch to a closest orthogonal view using that custom tool. And I've also got that view snap tool up here on my toolbar. You'll see me use from time to time. What I need to do is go through here and be able to select all the independent grids for these RBEs. I'm going to make use of the visibility checkboxes in the tree and turn my solid elements off. I'm also going to want to create, I'm going to delete these groups because I'm going to create some new ones. I want to create a group of the independent grids, and then I want to create a group of all the grids on those surfaces that I want to keep, that I want to use in order to create new rigid elements, because essentially that's what we're going to do. We're going to create new rigid elements. We're going to maintain the independent grids. So if you perhaps had CBUSHs attached to those, you had beams attached to those, it would maintain that connection and you wouldn't lose that interface. So I'm going to make use of the data table to do this, and my selector entity, I'm going to change that to element. And I think I already have it set to select all inside and select multiple. Yes. And I'm just going to draw a box using the hold the shift key down and drag the left mouse button. And you can see it populates my data table with all the rigid elements. I only want this category, this column with the independent nodes. So what I'll do is I will go and update multiple columns, and rather than uncheck several columns, I didn't mean to expand that so much. Rather than uncheck multiple columns, I'll uncheck all of them and just recheck the independent node. All right, the next thing I'm going to do is create a group of those nodes. So I'm going to copy that list to the clipboard. And I'm going to right click over here on groups in the tree and create myself a new group. Independent grids. Okay, group, node ID. And since those nodes are already in the clipboard, I can go to the pick methods and just select paste. And those grids are in there. So I can close that data table now. We're done with that. We're going to do two more things. We're going to delete model element. We're going to delete these rigid elements. The reason I don't use the delete model mesh command is that would take away the independent grids. And again, I want to preserve those. So I'm going to delete model element. I'm going to delete those 10 elements. And if we go in here and look, this is what I want to point out to you. One thing, the reason I do the next step. The next step, I'm going to delete nodes because it left some of these orphan nodes in here where the RBEs were not connected. You look along this line here, there's a line of nodes here. If I turn the solid elements off, they're going to go away. But there's a line of nodes here that still shows up. And those are orphans left over by the RBEs that may still be associated with the surface. So if I created new RBEs based on nodes on the surface, it's likely to pick these up again. So what I want to do is this next step, we're going to go ahead and delete all the nodes except for the independent grids. So here's how I'm going to do that. I'm going to delete model node. And I'm going to select all. But what I want to do is I have this group of independent grids over here, called that we created that group. I'm going to use the exclude, and I am going to exclude those grids from my selection. And it will delete any grid that is not associated with an element or not excluded by that command. Now you see those orphan nodes are gone. All right, so let's grab and we'll create another group. I could do this without creating a group, but just creating a group makes it easy. I'm going to create a new group and I'm going to call it new independent grids. And what I'm going to do now is I'm going to group node ID, and I'm going to leave my solid elements turned off for the moment. And I am going to change the method to on surface. I want to make sure I have pick all inside on so I don't grab any surfaces that I don't want. I only want the surfaces on those holes. If I hit the highlighter button, you'll see my selection. Hit OK, and I have two groups. One with my independent grids, the original independent grids, which may or may not be connected to other beams or CBUSHs in your models. And we have our new dependent grids based on the new mesh. Turn my solid elements back on. Okay, so the next step we're going to is going to create all 10 of these RBEs at once. And so the command we're going to use is mesh connect rigid. And since we have groups, I could select these one at a time, but since we have groups, and if we had 100 of these to do and have taken the few minutes it would take to make the groups, we would appreciate this method more. I'm going to hit more there, and that gives me my source nodes. Now, in the rigid connection options, it asks me if I want to create an RBE2 or 3. I'm going to create an RBE2. I'm going to leave the dependent degrees of freedom as they are. Target node selection, I'm going to set this to user defined. And I'm going to select the nodes, click the select nodes button in the dialog. And again, I'm going to use my group, new dependent grids that we set up earlier. And it shows you what those are. I'm going to uncheck maximum distance from source to target, since we don't really know the distance around the circle. And since we may have more nodes, more than 10 connections around each surface, I'm going to uncheck maximum targets per source. I click OK. It previews my target nodes. Click OK again, and it creates my RBE2s for me. Okay. Hopefully that will help you some in the future. Okay. I hope that was helpful, like I said. And if you have any questions about that, please feel free to email me, and I'll help you or make some supplemental video to post out on our YouTube to help you along with that. And that technique can be used if you have disconnected mesh on a surface as well. You would just choose the nodes on curves rather than on surfaces. We went through the steps just to recap. We created groups of the independent grids, deleted the orphans, excluding the independent grids, and created groups of the new dependent, and then used the mesh connect rigid command to create new RBEs. Okay, we've got two methods of creating bolted connections. There's two common methods. One of them in FEMAP, this hold-to-home fastener API. That is shipped with FEMAP, and it asks you to select a set of curves on the top and bottom of the bolted interface. And one advantage of using a beam element is, and if you have the need to use bolt preload, you're going to have to use a beam or bar to create the bolt. So the API, one thing you need to note about the API is it creates a beam diameter based on the hole. So if you select the inside of the hole, if you're modeling clearance holes, for example, if you modeled a 1-inch hole for a 7/8 inch bolt, it's going to create a 1-inch diameter beam. So you may need to edit that to actually make it your size, depending on how your holes are modeled in the film. It does create one bolt at a time, so it can be a little tedious. And you can modify, if you're a savvy programmer, you can modify the API to select surfaces. If you've got, if you desire a washer region around the bolt. And I've done that. I'll just briefly show that. I'm not much of a programmer, and I had to get some help from one of the guys in the office who is much better at API programming than I am. And then you would simply retrieve forces from the beam elements and complete hand calculations to determine your bolt margins. So let's jump into FEMAP and see what that looks like. All right, so I have this model here. It's just some plate elements And what I had, yeah, let's use this one. A little more colorful. Let me turn that selector entity off. So you can definitely use a manual method to do this. We could go model element and create rigid elements. Actually, just let's use our API there, meshing, and we can create rigid elements, spider curves. I'm going to undo this in a minute. And then we could use our mesh connect coincident link command to select those center grids and create a beam in between them. We're going to do that with CBUSH, so I won't go through that right now. But what I'm going to do is go back and we'll go to the API, the hole-to-hole fastener. It's under the meshing. And again, this is shipped with VMAP, so it's not only a nice little tool to use, it's also a programming example if you need to modify it for, say, to select surfaces, as I did. And I'll show you that. So I'm going to grab the hole-to-hole fastener. It asks for the curves at the bottom and the curves at the top. It really doesn't matter which one. I mean, I like to, remain consistent. So if I start going one direction, I'm going to use that direction for all of them. That means, end A is here and end B is here, all of my beams. And getting away from me there. So we'll just go ahead and create all of these. And be careful that you don't do this, that you don't grab all four. That will be a problem. You need to grab one side of the interface, hit OK, and the other side of the interface. And that creates your beam. Okay, so we can take a look at the beam property. These are 1-inch holes in this. So what we might need to do is we might need to edit that beam property. And we would just go to the shape option here and say change shape and enter 0.4375. If we wanted a 7/8 bolt, whatever your bolt is. And that would update the property. And as I said earlier, if you wanted to use bolt preload on this, you could apply bolt preload to the beams, or if these are par elements, you could apply that. And I'll just quickly show you how to do that. We could go load, create a new load, and then under load definitions, we create bolt preload, and it's going to put it on elements, and we'll put 350 inch-pounds on there, for lack of better information, and hit OK. And then what I'll do is, instead of selecting these one at a time, I could say method by type or by property, and I could apply my preload there. Okay. So everybody see that, hopefully, and hopefully that'll help you out. One thing I did, I'm going to undo this a little bit. Let's see. Yeah, we'll use this model. One thing I did is I went ahead and created some washer regions. Now your hole-to-hole fastener, let me turn that coordinate system off. We're going to use that in a little while. But our hole-to-hole fastener, you're not limited to selecting just two curves. I mean, I could use that meshing hole-to-hole fastener, and I could select all four of the curves there at the top, spin it over, select all four of the curves at the bottom. And it would go ahead and do that. This may be good enough. I mean, it doesn't take the internal nodes on the surface, but it does get the outer nodes and the inner nodes, and it's still basing the radius on the inside circle. So if we look at our beam property again, we'll see that that came out to 1 inch. Modify, edit property and shape. And yes, so 0.5, we can change that again. Hit OK. Right. And just very briefly, since I'm not much of a programmer, I'll show you this. I'll open that API, the hole-to-hole fastener first. And why did that not open? There, it did open. And you can see if you scroll down through here, you can see where it starts telling you to select curves, FE curve. It has everything in here to do with curves. And so everywhere, it has curve in there, you could go in and change the surface. So it's a little more involved than that, but it's basically, that's it. So let me see if I can open this one. Yeah, so here, I went in here and changed the surface. The only thing is, when you get down to the loop where it has to determine what size beam it is, you really have to hard code that in. And here's what that looks like. So, I mean, it's not a hard thing to do. I'm going to close this up and use that API. So I'm going to go custom tools, meshing, hole fastener surfaces. And it asked me for the surfaces on one side of the interface. And then the fastener radius. And then the holes on the other side. One thing it might, if I was better at programming, I would have fixed it to where it stored that radius instead of ask for it every time. So that's one thing that could have been done, and I'm sure can do it. But if we look at the beam property now, we go modify, edit property. Then our shape is the correct size. Okay. So hopefully that provides you some help with using the hole fastener command and getting it to do that on surfaces as well. Okay, I'm going to delete all of that, and we're going to look at how to create a bolted connection using a CBUSH. So what we want to do, this is actually my preferred method of modeling a bolted connection, is to use an RBE2, CBUSH, RBE2. So the quick way to do this, the steps we'll take is we're going to create RBE2s at each side. We're going to make sure we have an orientation coordinate system for the CBUSH elements, with the x-axis of the CBUSH being the axial direction of the bolt. And we're going to make these zero-length CBUSHs in the end, so they will require an orientation coordinate system. So this is an important step. And then we're going to create CBUSH elements automatically, and then we can collapse them. And again, this is something that can be done totally through the API. If you're a good programmer, you could create this entire API that starts with holes and two interfaces and ends here with only a couple of button clicks. And then again, the results, we would just grab forces or bush forces and complete hand calculations to determine both bolt suitability or the joint suitability. All right, jumping back into FEMAP. So our first step, I've already got a coordinate system created, and I just created that using the model coordinate system command. And if anybody needs to see that, I can go through that real quick just to create a second one that we don't need. But I'll just use the XY locate, and it doesn't matter the location of the coordinate system. It just needs to be oriented properly. So I'll just grab the origin. It wants a point on the x-axis. I'll grab a node there, and a point on the y-axis. I'll grab a node there, and again, it creates a coordinate system for me. I'm going to make sure that coordinate system 3, which is this one, is active. So it'll automatically create our CBUSH elements in that coordinate system, and we won't have any tedious updates of, 5 or 6 or 200 CBUSH elements to make sure they're oriented in the right coordinate system. All right, I'm going to turn the display of the coordinate systems off, get them out of the way, and we're going to use spider surfaces command, meshing, and spider surfaces again, and we can just and it doesn't matter if we go top and bottom to here. We're going to go ahead and just create them all on the bottom. Have all my RBEs created. And here's what I can do. Again, I'm going to go ahead and make use of the visibility checkboxes and get the plate elements out of the way. Again, I'm going to use my data table to get the independent grids because I want to create CBUSH between the independent grids of each of these CBUSH pairs. So I'm going to use the data table to get that list. Again, we don't need to group it. We could group it, but we don't necessarily have to. I am going to do that, and I'm going to again edit the table and turn off everything except for the independent grid column. And I'm going to copy that list to the clipboard. The command we're going to use now is the mesh connect coincident link. Now it asks me to select the nodes to link if they're coincident, and I want this list of nodes. So I just copied to the clipboard. I can go to the pick menu and select paste and paste those into the selection dialog. Going to hit OK. My coincident tolerance, I happen to know that's about 1, but we can measure that if we want to, just between one or the other of them. And yeah, we can round that up to 1. Okay, now here's what we could do. We can create rigid DOF springs, spring dampers, or gaps in here. I'm going to choose spring damper. We want to go ahead and choose CBUSH elements. Our coordinate system, you can see our active coordinate system is already set here. That's going to be our orientation. And instead of API Fastner, I need a CBUSH property. So I'm going to click on the create new property icon, and I'm just going to give it a good infinite stiffness here. Leaving the drilling degree of freedom of the bolt free. And we can give this a name to keep our model nicely organized. I'm going to click OK. Click OK again. And you can see it created our CBUSH. All right. So the next thing we want to do is we want to collapse these into zero-length CBUSHs. So I can do this a couple of ways. I've already got these grids in my clipboard, or I could turn the rigids off, and I can use the tools, check coincident nodes, and just simply select the nodes off the screen. From our measurement in the previous command, we know that's 1. So the action I want to take is not merge this time. So typically we use this to merge coincident nodes to get rid of free edges in our FEM. But this time I want to move only, no merge. It wouldn't not merge the nodes anyway to prevent element corruption, but I want to move those, no merge. I have my choice of moving to the lower, higher current location, lower ID, higher ID, or to the midpoint, which is what I want for this one. And I choose there. I choose the midpoint. You can see my rigid elements, my plate elements, and I have my CBUSH elements created here. And I can verify the orientation of those CBUSHs using another API that is, I believe, is shipped with VMAP and model query, CBUSH coordinate system display, and we'll just select those CBUSHs. And it shows, yes, that the x-axis of that CBUSH is in the axial direction of that bolt. And that's always a good thing to verify. And then you turn off that display in the same way under model query and CBUSH coordinate system display reset. Okay, so just to recap real quick, we created a bolted connection using 2 methods, using the hold fastener and a preferred method where we created RBE, CBUSH RBEs. We verified the orientation of the CBUSH. And again, we just grab forces from our analysis results and do our hand calculations. So it is, I think we're running close up on the hour, but if anyone has any questions, I can't see the chat window. So if anyone has any questions, either Chris or Dennis or somebody can read them out.
Yes, there are some questions.
Try to address them. The other thing is, here's my email address, and this is my cell phone number. If you have questions, comments, or need further help on any of this or any other topic, feel free to reach out.
Okay, Russ, we have a few questions for you. The first one is, do we offer training, and is there a training class coming up?
Yeah, there is. We're trying to put together a training class in January. So we have an introductory class to FEMAP, which teaches the basics of FEMAP, from some basic geometry creation through meshing and several types of analysis and post-processing. So that lasts a week. And like I said, we're trying to put one together for January.
Okay, the next question is, custom tools, spider curves does not include rotational DOFs in the RBE2. Is that an issue?
Probably not for solid elements. I have not known it to be an issue anyway. So, I mean, I use that API all the time, and I've not known that to be an issue.
Okay, the next one is, does FEMAP update the RBE element even if you pick the nodes node by node on the initial step?
Are you talking about grouping the nodes? Yeah. I mean, if you created the node by node, so if you're grouping these nodes, you can certainly group them pick by node by node. If you, for example, if you didn't have geometry, there's some ways you could pick those nodes. Let me just kill off an RBE2 or so. And if you are going to create a group of the nodes, around that hole and you didn't have geometry or curves, you could still do that. That would be a little bit more tedious, but if you hold the control key down, you have the ability to do a circle pick, or you could select them one at a time. And then, yeah, then you could use the same mesh connect rigid command to create the RBEs. So hopefully that answered your question. If not, please feel free to reach out to me by email.
Okay, the next question is, I use 0 DOF spring damper for bolt forces instead of molding bolts. What advantage / disadvantage would it make in your experience?
Using the CBUSH rather than modeling the bolts. Well, I mean, if you use the beam, you could do it either way. I mean, the CBUSH to me is simpler than using a beam, but actually modeling, I don't know, I'm not sure if you're talking about a detail model of the bolt or the difference between using the zero length CBUSH and a beam. So, but
All right, the next one is, I think the location of cord can be important when cylindrical cord is being used and tangential and radial directions are being specified. Can you comment on that?
for a bolt, I'm not sure when you would use a cylindrical coordinate system for a bolt, but yeah, I believe you would, if you wanted to model a bolt in a cylindrical coordinate system, I'm not sure. I've never done that or seen it done. But yeah, the location of the coordinate system origin might become important there. So I've never done that.
All right, the next one is, any benefit to using mesh connect coincident link versus mesh connect closest link?
Closest link. Okay, so yeah, let me show you the difference between that real quick. Mesh connect closest link. So I selected the nodes to generate from. The nodes to generate to, I'm going to select based on that curve. And I'm going to select rigid elements. We'll just go ahead and select all. And that's what it's going to do. It's going to select closest one. It's going to pick one of the closest ones. But it's not going to generate all the way. So for creating, I guess creating the beams or CBUSHs, it may not matter as much, but for the purpose of reconnecting rigids to a mesh, it would. Hopefully I didn't misunderstand that question. I think between two, so if I created two B's here, use mesh connects, closest link, yeah. I think that would probably be about the same as using the coincident link. On elements, and yeah, we can use that bush property coordinate system. And yeah, so yeah, there wouldn't be that much difference. But if you grabbed a lot of them, it may only create one. So yeah, you could experiment with that. It probably work about the same way.
Okay, next one is it necessary to move node to node in CBUSH? Why we do that?
It's better to use a zero length CBUSH. It's better for your analysis results. It has something to do with the moments in the CBUSH. That was just my learning in FEA that you always use zero length CBUSHs or bolts. Sorry, I don't have a better answer for that. I can certainly dig that up.
Okay, the next one I can answer. The question is it possible to obtain the PowerPoint/presentation that you showed? Yes, we can make that available for you upon request. So Brent, I will send that to you. And if anyone else wants me to send that to you, let me know. Okay, and then the last one for now, at least, is what is the best method of modeling bolted connections for thermoelastic analysis?
That you would probably want to use beams. That is it's been a long time since I have done anything with thermal, but especially with yeah, I don't know if you're talking about heat transfer or thermal stress, but there is some issues when using RBEs with thermal stress. So if we go modify edit element, you have the ability to put a coefficient of thermal expansion here. And then if you set up an analysis set, we'll just in the bulk data, you have to change the rigid method to Lagrange. All right. So those are two things you would have to do. You would have to make sure your material, if you have a beam element in here, of course, you've got a material, and that material card would also need to have its thermal expansion in it. So you would need your expansion coefficient in there, of course. But the other issue with doing heat thermal stress with RBEs is that it may still cause high and fictitious stresses. So one of the techniques I have seen used is to use a large massless beam and apply a thermal expansion coefficient to that. Use a lot. Hopefully that makes sense. Instead of rigid elements. And there's a command in here. I don't think. Let's see. I don't. Yeah, I have a beam property in here. So there's an RBE in here. Element update. Convert rigids to active beams. So you can have an active beam property and you can select a rigid element and it will convert it to beams. So that's another easy way to do that. So like I said, it's been a long time since I have worked with anything thermal. So hopefully that makes sense and hopefully not anything misguided in there.
Okay, we have a couple more. RBE2s have ref temp set as 0. Can we change it to 20 since all other model has ref temp of 20 and this difference causes unnecessary stresses?
Let's see if I get it. Reference temp of a RBE. I'm not sure where the RBE reference temperature is. If you can elaborate there, I'll. Material card. It's a reference temp. Of course, you can change that to 20 or whatever units are. It's always up to the analyst to make sure your unit system is correct. You can change in a material card, you can change the reference temperature there. I am not sure where to change the reference temperature of an RBE. Pretty sure it's just the reference temperature for the model. And if you applied, let me look one more place.
So I think some people are trying to help you out. One person said set the init card in your run for the RBE2. And another person said probably under material in the RBU dialog.
Yeah, here's what the material under the RBE dialog does. Modify a element, and we grab an RBE. So here's what the material button does. So you can type in a thermal expansion, or what that does is it allows you to set a material, and it will set the thermal expansion equal to the thermal expansion coefficient of that material. And I'll have to look up if there's a way to do it using the init and the analysis run. I'll have to look that up. But if you'll shoot me an email, I'll see if I can dig that up and reply to you.
Judy is saying init card is temperature.
Well, yeah, you can set initial conditions in here. So if you have an analysis run, did I set up an analysis run? Constraints in this model. But yeah, you can certainly choose an analysis set for initial conditions there. You can have, so if you set up a body load in here, for example, 20. That's why it's not letting me do this.
They're saying Lagrange must be turned on.
That is correct. Already said that.
Got it.
Yeah. So you have to go into the bulk data, turn on Lagrange for rigid element thermal expansion. A rigid element thermal expansion is still problematic, and a lot of folks frown on using it. Hopefully that gave you some answer to that question. If not, please shoot me an email with some further information. I'll see if I can dig it up.
Okay, Russ, for the next question, can you put Keith's contact info back on the screen? Because they're asking a question that I don't think either of us can answer. It's about legality. He says, if I buy FEMAP license for 60 days and in that period make some pictures for my book and sell the book, is it legal? I would email that question to Keith. I don't think Russ or I can help with that. You might also have to ask Siemens directly, but I would reach out to Keith right there. And then there was one more question. Has the bug with regard to nonlinear static and bolt preloads been corrected?
Do not know. I wasn't aware of that. Wasn't aware of a bug there. In NX Nastran anyway. I believe there was some I believe that did not have to do with NX Nastran. So can't answer whether it's been implemented or not. I think that was an Autodesk Astran thing, the interface between FAMUP and Autodesk. If I'm not mistaken, I could be wrong there, but I remember something about that. But I don't know if it's been corrected or not. It'll probably be a future version if it hadn't.
Okay, I believe that's all for now. If I missed any of your questions, please just email Russ. And I think that's it.
Hey, thanks, folks. I appreciate you spending some time with us this afternoon. And feel free to reach out anytime.